Any of the carboxylic acid derivatives can generally be fairly easily reduced using LAH. But what about the carboxylic acid itself? So it turns out that's one of the more challenging ones. And the main reason it's so challenging is that if you attempt to mix a carboxylic acid with LAH, the first thing that happens is not the same thing that happens in most of these other LAH reductions. The first thing that happens here is we have an acidic hydrogen. And because we have an acidic hydrogen, that LAH, which is a very good nucleophile, but also can be a base, the LAH will tend to deprotonate the carboxylic acid first. Because you've got this extra negative charge right now, the carbonyl is less electrophilic. Now, if you basically push this hard enough, eventually your LAH may be able to reduce the carboxylic acid. And just like you'd see with an ester, we get an alcohol out as the final reduction product. For the most part, we're going to kind of leave the mechanisms alone here. As we've said with reductions in other videos, a lot of times the actual mechanisms of reductions are more complex than we might initially let them on to be. But it turns out if you really want to do this reaction, there's a better way to do it. And that's with a borane reduction. So using BH3, the same reagent that does a hydroboration reaction, and then following up with acid. So good thing to keep in mind here that if you have an alkene in your molecule, this probably isn't the best choice for reducing your carboxylic acid. But it'll give you the exact same reaction that the LAH does, but much milder conditions. So typically not a reaction we use as often, reduction of carboxylic acid, typically much friendlier to work with an ester. But you certainly can, under the right conditions, either harsh conditions with LAH or the milder borane conditions, you can successfully reduce carboxylic acid all the way to the alcohol.